Welcome to BI Basics 103, the data warehousing process. In this video, I'm going to talk about the process of building a data warehouse. It is a process, as I've pointed out before. It's not simply buying a product and installing it and having it work. So, in order to go through the BI process, you have to build a data warehouse first. There are a lot of steps involved. I've seen some companies where an executive, often the CFO, will go to a conference and see a balanced scorecard product, and they think that just by buying that product it can be installed in their organization and they'll have a balanced scorecard. But in fact, the work involved is in finding all the data spread throughout the company, bringing it together and putting it in a format that the balanced scorecard product can use. And of course, it's not just balanced scorecards. There are many other products that benefit from a data warehouse. But the idea is that to get the data together, you typically have to build some kind of data warehouse, and that is a long and involved process, or can be, certainly. So, in this video, I'll talk about the data warehouse being the basis for the BI solution. Basically, you'll go through the process of co-locating the data, consolidating it all in one place, making it consistent, and then whatever front-end tools you have can access it, and the business can start to achieve or receive benefits from that data warehouse. Now, the warehouse itself can be stored in several different physical formats. One be just regular relational tables, or one or more cubes. And that's the more common approach, certainly today, because cube building technology is relatively easy to use now, very accessible, but it provides some tremendous benefits over just standard relational tables. And one of the terms that you'll see used throughout are data warehouses and data marts. The point is that those are exactly the same as far as how they're built. The only difference is scope. Typically, you talk about a data mart as being focused towards one area of the business, such as an HR mart or a manufacturing data mart or a sales or a finance, what have you. Those are very focused. A data warehouse, in theory, is the entire business. But the process of building them is exactly the same, so I won't worry too much about whether we're building a warehouse or a mart. It's all the same process. This image gives you a good representation of the overall process of building a data warehouse. It even includes users consuming the data from the warehouse at the end of the process. I'll use this diagram in a series of slides to illustrate the entire process and discuss what is happening in those different steps. So the first step is to identify the business problem. One of the mistakes that some companies make is the IT organization will say, well, we need to build a data warehouse, but they can't really answer why, except that they think they need to because they'll achieve some benefit if they do it. Really, the best thing to do is identify the problem. I guess the most generic problem I've seen businesses identify and still be successful is for someone to say, we need a balanced scorecard. But if you ask why, they can usually articulate a good reason for that. Oh, we need to better monitor our business. We're trying to grow. We're trying to beat our competitors. They typically have some good reason for wanting to better monitor their business, and that's what they think the balanced scorecard will help them to do. And in most cases, that is correct. But in other organizations, they have some more specific problems. We're struggling with our inventory, and we need a warehousing solution to help us track our production and our inventory levels. Or I've worked with some businesses before that are looking at the costs of, for example, drugs and the patients receiving them and the physicians prescribing them, and then if a physician is prescribing more drugs than another, are that physician's patients healthier on average? So they look at lab results and diagnoses and some of those other things. So there are a lot of different reasons for building a warehouse, and it takes really someone identifying a problem and saying, I think that a warehouse is the best way to tackle this problem. And what happens is that when someone identifies the problem to be solved, that leads to a couple of things. One is, what metrics should you examine? Metrics being measures or KPIs or facts, however you want to look at it, but basically, what are you trying to achieve? And what do you need to measure in order to do that? The other part is, how will you look at the data? I mentioned before a business I was working with, and they were looking at drug costs. So obviously they were looking at the cost, and it was by drug and by prescribing physician and by patient, and they also had some facilities and some other things in there. But that helps you define what you need to see and the dimensions or how you need to look at it. And what that leads you to do once you've identified the problem and you start talking about what you need to solve that, it leads into the design of the relational warehouse. This is often called a dimensional modeling, and the end result is usually a star or snowflake schema or just generically a relational data warehouse. But that structure that you build is driven by the problem that you're solving and what the people need to see in order to try to solve that problem, and how they need to be able to analyze the data. What dimensions, per se, are they going after? So that's really the next step in this, is kind of designing that relational data warehouse. Now what's interesting is that in a lot of cases, businesses will design a relational data warehouse and say, okay, this is generically what we need to collect and be able to examine, only to discover that they may not even be collecting all of the data that they need. So the next step is then to identify where is the data, and often it's spread throughout the organization. It'd be nice to say, oh, it's always in a relational database over here, we can pull that, but the truth is it's sometimes in multiple relational databases, and often it's not even in relational databases at all. It might be coming as a flat file, possibly from a mainframe or from an outside organization. In a lot of businesses, they have data inside of Excel spreadsheets that they have to somehow pull out and then integrate into the data warehouse. And that's not unusual, and you can certainly pull from all of these sources. But you just have to determine, where is the data? Is it already being collected? If it is, where is it? How do you get to it? Of course, if it's not being collected, then what process do you have to go through in order to collect that data? After determining where the data is and getting access to it, then the ETL process begins. And this in and of itself is an entire another process. ETL stands for extraction, transformation, loading, and this is the process of extraction, is accessing the source data and pulling it from wherever it is. And then transformation is where most of the complexity typically comes in. Imagine that you're in an organization and you have sales in multiple countries. Well, each country records sales in their local currency. Well, you cannot just take US dollars and Japanese yen and euros from Europe and just add them together to get total sales. That doesn't make sense. So if you're pulling the source data, you're pulling sales in local currencies. So the transformation, of course, is to apply some kind of currency conversion to those numbers before then storing them. That's one thing when you hear about relational data warehousing a lot, you hear that it's consistent data, and that's one example, is that all the currencies are in the same format. They are in a consistent format. In addition, because you're pulling from multiple sources, one source may have T and F for true and false, another may have 0 and 1, so forth. You have to convert all those into the same thing. You have to somehow, again, make them consistent. And so that's where a lot of the complexity in the transformations come in. And these can be as simple or as complex as you want to make them. One of the great things is that you can actually write your custom transformations in today, Visual Basic. With SQL 2008, you'll be able to do it in either Visual Basic or C#. So that's a nice benefit. Now, Microsoft's tool for performing ETL is, of course, Integration Services, often called just SSIS for SQL Server Integration Services, or just IS for Integration Services. But that has the ability to extract the data from these sources using OLADB or ODBC connectors or SQL Native Client and some others. But then it can pull this data and then transform it using a variety of built-in transforms, or you can actually build your own and add them in. Then the final part, the loading part, occurs when the data, this transformed, now consistent data, is loaded into the relational data warehouse. Now in this particular diagram, I show it going straight from the sources through Integration Services into the relational data warehouse. In reality, in a lot of cases, there's a staging database in between, where you pull from those sources and drop it straight into a relational warehouse, and then you perform transformations on it. And now that it's all in, for example, if you dropped it in SQL Server staging tables, then you can just perform some T-SQL against it, and it makes it easier sometimes to manipulate. So don't think just because you see the diagram this way, I'm saying you can't have a staging area. You certainly can. This is just a simplified view of that. So once you've pulled the data from the sources and performed all the transformations and then loaded it into the relational data warehouse, again, you could be done at that point. You could be done with just a relational data warehouse. However, in most data warehouses today, you then go on to build one or more cubes. And there are some great benefits to having cubes over just staying with a relational data warehouse. One of the biggest is speed. Cubes are built for extremely fast access. That's what they're for. In addition, they can calculate aggregated values ahead of time and have them stored so that when you go to perform a query and you need a high-level number, it doesn't have to add up potentially billions of records in order to get that number. It's already calculated in the cube and returns it very quickly. In addition, the cube is natively multidimensional. It understands dimensions and hierarchies very well. So it makes it much easier for users to then manipulate and drill up and drill down using a variety of tools. So the cube building process, again, that's also a process, and it can have calculations and KPIs and be very complex. But it is a normal step anymore in most data warehousing projects, and I think is one of the most important things you can do. In fact, I spend the majority of my time working in analysis services and working on cubes. After building the cube, the final step is to deliver the data. Now again, even if you do build cubes, that doesn't mean that you can't pull data from the relational warehouse and the cubes. You can certainly do that. I've worked on a lot of systems where some of the reports go against the cube, some go directly against the relational data warehouse. But in general here, of course, I'll assume that we'll be pulling the data from the cube, and you see that in this particular diagram. They're users of several different tools from Microsoft: ProClarity, Performance Point, Excel. I don't show SQL Server Reporting Services on here, but certainly that is another one that could be there. You can also build custom applications, be it in .NET or Java or anything else. As long as there's some connector back to the cube, you can show that data. And that allows you to integrate the data from a warehouse into line of business applications. People might not even know that it's technically data warehouse data. They may not know they're doing business intelligence. They're just pulling data, or the application they're using the day-to-day is pulling data from the data warehouse. So to embark upon a data warehousing project, what kind of skills do you need? Well, clearly one of the things that is extremely important to have are good SQL skills. And that's because the relational data warehouse, there's going to be a lot of manipulation that goes on, and typically you're pulling from a relational source, and then of course you're loading into a relational source. So there is a tremendous amount of SQL going on, and a lot of the transformations end up actually being SQL based. So having strong SQL skills is critical. Data modeling skills is important, especially when it comes to doing the relational data warehouse, and you want to make sure you get that right. There are a lot of issues to that, or can be certainly, especially if you're trying to track history on when changes occur in products or people and so forth. Now, I showed that the ETL is typically done in a data warehousing project with Microsoft technology using integration services. There are many other ETL tools, but of course we're sticking with the Microsoft BI stack here. And integration services is a very robust tool, very powerful, and as such there is a bit of a learning curve to it. So therefore I think it's helpful to get someone or several people in the organization ramped up and proficient with integration services, whether that means classroom training or reading books and blogs and so forth. Whatever works best for those folks, having that expertise is very important. In addition to integration services, analysis services expertise is quite important as well, and having someone who understands how to build cubes and how to later access those is very important. And one of the things that person should have are MDX skills. Now, MDX is the language you use to query cubes, just like you use SQL to query relational tables. MDX is can be a fairly complex language. It starts off looking nice and simple, and then it quickly gets more complex. And I'm not saying that you have to have an absolute MDX expert on every project, but I've also talked to people who say, well, I've built several warehouses and I've never used MDX. Well, it's actually difficult to do a warehouse of any size or complexity without MDX. Just the calculations that you build are done in MDX. If you do any kind of security, that's typically done through MDX. So having MDX knowledge is certainly very important. And finally, .NET knowledge is a plus. It's not required, but it's helpful sometimes when doing transformations. If you need full programming capabilities to perform a transformation. Also, of course, it's necessary if you're going to build any kind of custom application that accesses the data in the warehouse. So in summary, the basic steps in the data warehousing process: identify what problem the business needs solved. And in order to solve that problem, that means what are the metrics, what measures, what numbers do you need to see, and how do you need to see them in order to solve that particular problem. Once you know what metrics are involved and what dimensions are involved, then you can design the relational data warehouse based on that. Now, don't misunderstand, the design of that data warehouse, that relational warehouse, is going to change probably quite a bit throughout the process, but it shouldn't change as far as the overall dimensions and measures. You'll probably add more measures and you'll modify the dimensions slightly, adding new attributes and things like that. But designing that up front lets you then move to the next step, which is, okay, we now know what data we need in order to solve this problem. Are we already collecting it? If so, where is it? If not, then we do need to start collecting this. But for the data that already exists, can I get access to it? Once you've achieved access, then it's time to start the ETL process. You can access it, so now extract it and go through that whole transformation process to make it consistent, consolidate it, and then when it's all consistent, load it into the relational data warehouse. Now, I should point out that in a typical data warehousing project, the ETL portion accounts on average for 60 to 80% of the entire process. Now, that may sound incredibly high to you. Wow, up to 80% of all the work's done in the ETL. Well, there is a lot of work in the ETL. It typically is the most time consuming. But you may not spend 60 to 80% initially. What happens is that it is touched more frequently over time than anything else, again, on average. But that's because users are surprisingly expert at getting bad data into the system, no matter what you try to do to prevent that. They'll always find a way to get bad data in there. And so on a regular basis, you'll have problems occur that have never occurred before because somehow bad data has gotten in a way that it's never gotten there before. So you have to go in and fix the ETL to handle that new situation that's never popped up before. And every time you'll do that, you'll think, okay, that's the last time I'm ever going to have to touch this, until it happens the next time, which usually isn't too far off. So once the ETL is done, and again, ETL may not ever technically be completely done, it always needs a little tweaking here and there, but once that's finished, then it's time to build cubes. And you go through the cube building process, and once the cubes are built, you start giving users access to it with one or more tools, often a wide variety of them. So that's the process, and now it's time to move on into the next video, in which I'll be talking about why data warehousing projects fail and what you can do, or into some of the more technical videos such as integration services or analysis services. Thank you.